Honors Physics, Day 133, Homework, Electrostatics, problem number 32. This is basically almost the opposite of problem 31. You're given the speed of the proton when it accelerates across this field. And once again, this one will go with the field because it's a positive charge. It'll accelerate that way. When it hits the plate, the electrode, it will have a velocity, so you can figure out the kinetic energy of the proton. So the first thing you'll do is figure out the kinetic energy of the proton, 1/2 times the mass times the velocity squared. You're given the mass up here. That's the mass, and the velocity is given in the problem, the 10 to the 6th meters per second. So you'll have a value for the kinetic energy that the proton has when it strikes the other electrode, the negative plate. And then, just like the last problem, in reverse, you're going to have delta V equals delta U over Q. We're looking for the potential difference, delta V. And we'll have the kinetic energy, which will be the initial potential energy that the particle had, the proton had, because it was transferred into the kinetic energy at the end. And we know the charge of the proton. So bottom line, we will know this from our first calculation. And we'll know this because the charge of the proton is the 1.60 times 10 to the negative 19th coulombs. And we'll come out with our answer in joules per coulomb, which is called a volt. And that's the entire problem.